I see. It's sweatshirt day.
Oh, yeah. My house was like 67 this morning, and I kind of just refused to turn on the heat. So I'm rocking it with my favorite old sweatshirt that's
It's like
like
rotten pumpkin color.
yeah, and like raggedy on the arms and shit like that. Like I don't. It is comfy though, comfy AF.
When will Zoom allow us to put reactions in the chat?
I don't know. I think it might just be that that I'm not like a Zoom associate or whatever the Twitch version is. You know.
You can press the Windows key and period to get emojis if you're running Windows and use it as your action.
Fancy. You're probably not going to find PogChamp though.
Just upload it as an image. Easy.
True. Yeah, that sucks. You have to download it. Ugh. And it doesn't render those emojis very well. What is that? I can't even tell what those emojis are. Okay. All right. -1 for the Zoom chat rendering emojis because that sucks. Y'all staying warm today? No. My heart remains cold. Well, yeah. I mean, it's good to test out your heat now instead of like I was one semester I was holding off on turning on my heat because I wanted to save power. And then it was December and dropped to like 20 degrees and I turned on my heat and it didn't turn on. And I was just like, I regret my decisions. So what did I say I was going to talk about today? I know I wanted to talk about promises and the XHR stuff some more. Okay. Anybody have any more questions about forms? And I probably should at least touch a little bit on sessions too. That'll be fun. I think I can get through sessions pretty quick. You don't have to know exactly how they work, just kind of like have a general idea. Yeah, it was freezing this morning. Well, it wasn't freezing, but colder than I expected. I opened the door and my cat darted out It was just like on the upstairs balcony. But yeah, she like darted out and I'm like, that's cool, you can hang out there. And then like 2 minutes later, she's like, I made a mistake. I want to come back in. We're going to do, I'm not going to do async and await just because that's just kind of syntactical sugar on how to do real promises. Like it does the exact same stuff under the covers for the most part. So maybe near the end of class I'll get to that, but like it's way more important that you understand how basic promises work. First, how to use them is what we'll talk about today. And then for project 5, we'll go back and look at promises again, do a refresher how to use them, but also talk about how to make them, because in project 5, we'll need to make promises so that we can, like, for example, make 15 promises and then use promise.all to create a new promise that resolves whenever all 15 of the original promises resolve. So you can kind of like do some serial, like when this promise happens, do this one. When this promise happens, do this one. And then you can be like, all right, now send out these 15, not to int this next project. I'm not sure. What do you mean int? I don't know what int means. That's why I feel so bad getting into LOL sometimes. Oh, run it down mid. Okay. All right. Intentionally feed. All right. Yeah. Yeah. So even I, like, half of the time I'm playing LOL, somebody's like, God, I don't even know what some of the terms were. I can't remember them because I didn't know what they meant. And they're just like, you're such a this. And I'm like, I don't think that's a compliment, but can you explain? And they're like, oh, God. I don't know what intentionally feeding would be in the terms of project. Would that mean just like getting it done early so that I have less to do later? Not doing it at all. Doing trash on purpose. Yeah, okay. Like hard coding the responses my Postman tests look for. I mean, everybody does kind of, well, not everybody. I think like at least a third of the class turned it in at like 11:45 or later. It depends on who's asking. Yeah, fair enough. Inting would be like hard coding the wrong responses. Trying to cheat and failing. Yeah, okay. All right, let me get this screen up and we can start talking about whatever the hell we're going to talk about today. Where's my chat? All right. Speaking of LOL, when's the next gaming league thing? The ACC, whatever it was, ACE? I don't know. LCS? Max is like, I think it's and then hit enter. Like, you could have just waited till you figured it out.
Yeah, but that's not fun.
First post.
Should have kept putting periods there and just kept typing periods until he begged
Yeah,
me to stop.
I have access to their chat. So Friday, 9 p.m. for their ace match.
Oh, word. I
There we
think I'll be there. I think I'll be around for that.
I don't know if there's going to be a viewing party, but we can make one.
I mean, viewing party just means we all sit in a Discord channel and watch the stream, right? Like,
yeah, basically.
Like, when is there not a viewing party?
For most games, actually. It's all about the Clemson esports officer bias, what games they care the most about.
Okay. So they didn't do the viewing party because of League. They did it because of, like, Rocket League?
I think they did it because of... I think I did it because it was the first day of the match. I don't know if it'll be on stream this time,
Oh, well, if it's not on stream,
but
that's terrible.
I think we'll be like independently streaming, but it's not going to be on the big stream. I'm
Yeah.
not sure. I'll check it out.
Diabolical tournament on Saturday. If you want to watch an absolute clown fiesta, you know, I don't think I want to watch Diabolical or a clown fiesta, so probably going to pass on that one. All right, so what do I have in my Sublime? Can I show that? I'm going to pull this over here. Okay. Let's see. Is that the right? Yeah, okay. So this is promises, but I said I'd talk about sessions first. So let's go over to the redacted server thing. Okay. So the way sessions work, sessions use cookies. But with normal cookies, the browser can normally change them. Or even if you have like a cookie with a secure flag on it, which or like a read-only flag or something like that, those things make it harder for you to change the cookie in the browser. But somebody can just send a custom HTTP packet without using a browser that has the values of whatever cookies they want in them. So like saying, hey, this browser is logged in as username Craig B in a cookie. That's not great, right? Like that presents some problems because that means anybody that sends you a packet with like, you know, get/user HTTP 1.1, and then you do like some headers, host, and then all this stuff. And then you have cookies. And one of the cookies might be username equals Craig B, right? Like that's all when you go, the way cookies work, and I guess I should take a step back and talk about how cookies work. Normally a cookie is something that when you get a response from a website, it has some set cookie headers like set cookie, and it'll have some stuff like the key and then the value, and I can't remember the exact syntax. You don't really have to know that because everything nowadays just like creates cookies for you. And then it'll have stuff like lifetime, which will either be a time or session. If it's session, then it'll stay in your browser as long as your browser's open. As soon as you close your browser, it'll go away. Some other cookies with lifetimes that actually have numbers in them will stay in your browser even if you close it, but they'll disappear after a certain amount. You also have stuff like secure, which means only send this cookie back to the server when it's when it's an HTTPS connection. And then you also have something like path. So the way cookies work is a lot of times like Google.com, for example, will set a cookie and it wants anything under the Google.com subdomain, like, you know, docs.google.com or messages or anything like that. It wants your browser to send that same cookie back to them every time you hit any of those things. But if your browser goes to yahoo.com, your browser should not send that cookie back. So all cookies are specifically set to a host name or like a range of host names based on like, you know, star.hostname.com or something like that. So I think that's host, right? So host, and then I think these are separated by semicolons. I'm totally pseudocoding this because, like I said, you really don't know have to know the exact format of it. When you read the value of a cookie, like in your inspect panel or something, all these pieces should become visible. Also, a lot of times your browser will just have like a way to view the cookies in like a table format where you can be like, oh, there's a check in secure. Oh, this has this lifetime. Oh, this, that, and the other. So there's also a path, which almost nobody uses nowadays. Path equal or whatever it is, equals or colon. And the path normally is slash, but you can have a path where it's like, okay, send it to any host name or just send it to this specific host name or send it to any host name when you're accessing /path/admin and anything under that, right? So it might be something like this. For the most part, everybody's like, you know what, any path that you access on the server, send this cookie along. But it still wants to check the host name. So you could have the exact same key value pair. You could have like, you know, I don't know, like English language, although we have headers for this nowadays, but language English or something like that. And you could have a cookie for that sends it to google.com. And you might have another cookie that sends it to yahoo.com and all this stuff. So cookies are a way for your browser to hold on to information. And then when it goes to a new website, it doesn't send all this stuff. It doesn't send like all that junk. It just sends when it's talking back to the website, it just sends key value pairs. So it'll be like user equals Craig B, and then a semicolon, then another cookie 2 equals that, and a semicolon, something like that. So all of your cookies kind of get rolled up into one header, and it's all the cookies that your browser thinks applies to this website with this HTTP or HTTPS protocol and all that stuff. There's also a read-only flag in here. And the way the read-only flag works is it says, look, you are not allowed to use like the JavaScript console in your browser, or I don't know, go into your browser dev tools or anything like that and change the value of this cookie. That does not mean it's secure, because at the end of the day, if I have a cookie that says my user's Craig B, I can just craft this packet and send it to your server, right? So once I see how your cookies are formatted, and if you're storing my username and using that to be like, oh, well, I sent them a cookie that says you're Craig B, and that means you're Craig B. And if I see that in my browser and I change it to like Trump, and it lets me log in as Trump, that's not a good thing, right? So don't trust the values inside cookies like this. Topical. Yeah, I know. Are cookies made by the website or the browser? Could be both. Traditionally, the HTTP response from a website will have set cookie commands, but JavaScript can also create cookies inside the browser as well. So there is a way to make this secure, right? We could just say like, when you do set cookie from the server, you could make a hash out of it, right? You could just, the same way that we do passwords, where you're like, password plus salt and send salt, right? And I'll move this down here so it's different stuff. So like on the server, I could be like set cookie hash this password salt, right? And so I could actually turn this into a hash, or I could turn it into like an encrypted thing. It actually would be better to encrypt it so I can decrypt it later. So if I encrypt it and I never send out the key, and this is the way before we started using the gray and orange page at Clemson, we did have stuff that actually did something like this, YPT, right? So and this is pseudocode obviously, but we take like, and this would be username, right? So we have a username, we encrypt it with this key, and then later on when we, receive cookie from browser, decrypt cookie with same key, make sure username is a username, right? So that is a way to kind of make the cookie kind of secure, right? It makes it opaque. So like, as long as nobody else gets that key, and it's a long enough key that makes it a really sparse space of encrypted values, where like maybe 1 out of 1 million or 1 out of 10 million actual string values that could exist in that cookie actually decrypt using the key to a username, then that's relatively secure. There is some things that make that less secure. Like I could just see your cookie. So I could be like, watch Wi-Fi traffic to clemson.edu. And on an open Wi-Fi, and if you're not using an HTTPS connection, I could be like, see HTTP connection. And this could just even be, so without the secure flag up here, for example, this is one reason why you should always use secure. And this is also why recently browsers are like, hey, you know what? You're on an HTTPS web page with SSL and all that stuff, but one of the images this web page is telling me to load is trying to tell me to load it from an HTTP resource. And browsers have started kind of refusing to do that. The reason they've refused to do that, because you could be on like HTTPS, www.clemson.edu, and I actually saw this happen. Like I've used Wi-Fi sniffing on open Wi-Fi to catch people's cookies this way. And then this might have like an image tag, source equals HTTP www.clemson.edu/tigerpaw .png, right? So say we have this sort of image tag on the page. When your browser, back in the day, your browser would go get this, it would go get it over HTTP. But if you don't have this secure flag set, then it's going to attach your username cookie, which, yes, it is encrypted, right? But it doesn't matter if it's encrypted if you aren't also checking the IP address it comes from. So I could just copy your cookie, right? Like if I already know that it's a valid cookie and it'll decrypt correctly, I might not be able to be anybody, but I can be anybody that I can steal their cookies from, right? So I can see an HTTP connection over open Wi-Fi, grab cookie, use cookie, be person, right? Like it's pretty much that simple. So that's why there's multiple things like your browsers don't try and send stuff over HTTPS. Most sites should be setting a secure flag on their cookies. You shouldn't be on open Wi-Fi if you can help it. And you shouldn't be making image tags with hard-coded protocols. You should just be using this, right? Like all of these are mitigations that will help protect from that, right? And this needs a quote. But so remember what this / means. It's like use whatever protocol you loaded this page from, use that same protocol to load this image. So every request your computer sends to www.clemson.edu it'll generally attach that cookie, right? The encrypted. So instead of that, it might be, the encrypted value, but decrypts to Craig B, right? So, and it might decrypt to Craig B : timestamp. And this is actually timestamped, STAMP. There, yeah. Okay, so this is actually how Clemson used to do it. And when I started doing some of their IDM stuff back in like 2012, they didn't even have this secure flag on there, and browsers weren't preventing this stuff from happening. So there actually was a time I didn't see anybody actually take advantage of it, but I was just playing around and was like, oh shit. Guys, I need to do an emergency patch to login.clemson.edu because this isn't good, right? One other thing that on really secure websites, they also, on top of all the other mitigations we talked about, like the secure flag and making sure that you're not sending anything over HTTPS, and enforcing all of the people connecting your website to be on closed Wi-Fi. And that's more like a policy that HR puts into place, right? So you can't really do too much with that. But one other thing is they might say, this might have something else in it, and it might be IP client IP address. Right, so that means if I ever see this cookie coming from an IP address that like when I decrypt it, if the actual TCP client IP address does not match the value of the decrypted cookie, then I refuse it. Most people don't actually do that because it breaks a lot of stuff. Every time you drive down the highway and you're doing stuff on your phone and you change from one cell tower to another, your client IP address is going to change. So relying on client IP address is much more secure, but it also is going to be a much worse user experience for people. So making sure you have the secure flag and relying on HTTPS encryption is a good thing. making sure that you never link to anything on your webpage that's not HTTPS. Although right now those will just end up like broken images because browsers won't load that shit anymore. They'll just be like, nope, I know better, right? So those are things that you can currently do. And this is kind of the evolution towards session cookies, right? So this is just an encrypted value. The cookie, the actual username is still stored in the browser. It's just encrypted and has to be decrypted, right? So it's an opaque value. With sessions, I have like, okay, make some memory in web server or row in database. Get ID for this slot in memory, right? Put stuff in this memory like username or IP address or whatever. And this also this could also be table row, right? So you put all this stuff in memory in a server side thing. One way or another, where only the server has access to it, and then set cookie ID, right? The ID that you got that points to this table. So this is what sessions are. Instead of actually putting the encrypted value into a cookie, you put some huge long randomized string, which in practice looks the exact same and has almost all the same problems, right? But at least this way, like, even if they get the key to decrypt this, there's nothing to decrypt here. It's not, it doesn't have any value in it, right? Like all of the actual values that somebody could ever possibly edit, even if they get access to this key, are stored server side. So it's a little bit better protection. But at the end of the day, unless you're doing this, like making sure that you're putting IP address into this row and checking that the client IP address still matches, all of these other problems still apply, because if I have this row identifier in my cookie and you take it from me, you now have my session, right? So sessions are a little bit better, and they also allow us to store way much more data. There are length requirements on cookies, and also if you wanted to store for some god-awful reason, and please don't ever do this, but if you wanted to store like a JPEG image in a cookie or something like that, that means that your HTTP response to the client is going to have a cookie that's like 2 miles long. And not only is that going to break some length requirements, but it's also going to make page loads horribly slow for that browser, right? Because now you're like, before it even gets to the content of the web page, it's already pulled down 3 kilobytes of data or some crap like that. With this, you can actually put all kinds of data on the server side. And this stays the same length. So there's some added benefits to using it. The security improvements are not so great compared to using an encrypted cookie value like this, but that's what this is. So session cookies are kind of like a pointer. You give the pointer to the browser, that pointer points to memory on the server or a table row on the server's database or whatever. The one downside to these two methods, for example, let's say we don't use a table row, right? We just store it in memory on our Apache server, right? If we restart our Apache server, this will still decrypt correctly. If the client comes back to us with the same cookie and we've restarted Apache, this will still decrypt correctly. This memory will be totally gone. If we have 3 web servers behind a load balancer, and say you aren't stuck to one of them, so like the first HTTP request goes to server 1, the second HTTP request goes to server 2, up here, if all those servers have the same key, then they'll all decrypt this thing just fine, right? Like they'll all get the same values back out of it. That's not a problem. If you have 3 web servers and one of them has a memory entry that this points to, the other 2 are not. So sometimes if you're hopping between, you're talking to this progressive web app and you log in, and normally you stay logged in for like 6 hours, but in like 20 minutes it asks you to log in again. Chances are they have something that like sticks you to one of the servers. And so normally it works fine, and that server is the only thing that has memory about you. But if that server restarts and you get back to that server, or if it restarts or goes down and you get stuck to a new server, it's going to ask you to log in again. That's because they're using sessions and they're storing their sessions in memory. A way around that is if all of your web servers have this database connection. So if you have a database connection, and this is kind of what Redis is primarily used for, is caching layer, so like you can cache the answers from a database, or as a session storage thing. And Redis has actually got tons of tools for session storage and caching, where you can put something into a Redis database and be like, expire this information in 6 minutes or in 6 hours or whatever. And you don't have to go back through and clean up all your junk. It's just that'll just automatically delete itself after 6 hours. So if you want to have a session lifetime of 6 hours, you just set a TTL on that record in the Redis database, and that works for caching too. We're not going to be using Redis for session or for caching. We're going to use it as our actual primary database because that's a little bit more difficult, and I want you to understand all of the things Redis can do. That'll be Project 5, so I'm not going to talk too much more about this. But either way, if you have some off-site storage, and this even works for like if you have network attached storage on all 3 of your web servers and you just save the session to a file on that network attached storage, right? Then all 3 servers see it. If any of those servers restart, the file is still there, the database is still there. So this, you add more infrastructure, add more complexity, and you get more reliability. But the standard way of doing it and the way we're going to do it is we're just going to store it in memory. Any questions about cookies or sessions so far? Okay. So where's server? Okay. So in the code that I gave you guys, I said all that about how to do sessions, but you really don't have to worry about it because we're just going to use this extra package called Express Session. So we create our Express app, just like we did in the last one. And then we tell the app to use sessions, and we pass in a session config. The secret is how we generate the session IDs, right? And then we actually have things that we can put into the cookie, like secure, true. These are attributes that get applied to the session cookie. We don't really care about all that. This is not something that we want to be super protected about. If you were using this in the real world, and like their website actually tells you like, this is not a professional grade configuration. You need to read our docs if you're going to deploy this in production because this is not secure. This is just something to get you started, right? So we tell it to app.use session. App.use, by the way, is middleware. In Project 5, we'll be writing our own middleware, but the way app.use works is these get called in order. So for every request, like down here we have app.delete. So this callback only happens when a delete request, an HTTP method delete, comes in with the path of /db, right? That's the only time this thing gets called. App.uses get called in order of declaration for every HTTP request that comes in. Blah. So every time it gets an HTTP request, it runs this body parser thing. And this whole thing right here, it returns a function pointer. So app.use takes a function pointer just like app.get does. And then app uses that function pointer and calls it on every single request to modify the request. So body parser.url encoded, we pass in some stuff like extended true, blah, blah, blah. That generates a function pointer that then gets passed into app.use. And this is the first middleware piece that we're using. Session also returns a function pointer, right? So this makes a function using the configs we passed in and returns it. And we pass that function into app.use so that the second middleware piece that gets called for every request that comes in is this session piece, right? What that does is body parser actually creates rec.body the way that we want it. So when, let's see, when we actually do this form action, right, it generates it puts like this user ID, the name, the password, all that stuff. It puts it all into the body of an HTTP post, and it encodes it in some special way, right? I think we talked about that. I lost it, but it's encoded in some special way in the body. So the way it looks, and I can actually put this over here. No. The body of the request looks like user ID equals Craig B. And this is all plain text. So you should not be doing registration and login. Like, just because the password input that we have over here. Nope. Yep. Just because this is type password. Yeah. So like when you type into it, it shows stars. Right. Just because that's type password does not mean that it puts stars into the actual request that it sends to the server. You have to send that data to the server, right? So if you go inspect your connections, when you click submit, you'll see my super secret password. And this is why you should never send passwords over HTTP connections. In addition to always sending them as a post body and not a GET request. We talked about that already. So without this middleware piece, where are we? Without this body parser middleware, if we were to inside user exist, for example, or where are we, post user, yeah. If we were to call rec.body, we would just get this string back. And we'd have to chunk it up ourselves and URL decode each piece and create key value pairs for user ID and password and name and all that stuff. It would just, because this is the literal body of the request. And by default, Express, and more importantly, Node.js, says like, hey, here's the request. Here's the body of the request. You figure it out. But because we attach this middleware piece up here, this actually deletes the text value of the body and replaces it with user ID Craig B, password super secret, name C Baker, Craig C Baker. Yeah. So it actually deletes the existing rec.body, which is just that one line of encoded text, and replaces it inside the rec. So rec.body now is equal to this. So we can do rec.body.userid. We can do rec.body.password or .name, and we actually get stuff out. The reason that we get nice, pretty stuff like that is because this middleware piece has already done work on the request before it gets to any of our functions down here. And so, by the way, this is a little ES6. So this is equivalent. ES6 is a upgraded, 2016 version of JavaScript. But it is the exact same thing as doing const user ID equals rec.body.user ID password. So it's just a little fast way to do that. It's like, hey, these little curly brackets mean, hey, I expect rec.body to return me an object, right? And in that object, I want you to find the user ID and make me a variable called user ID. I want you to find the password in that object and make me a variable called password. So these kind of have to be named the same thing. If you want to name them differently, you'd have to do something like, I think that's the syntax. I can't remember. I'd have to Google it. But so it's a little fancy piece of like handy coding that y'all probably aren't going to be comfortable with. The body parser, it's not really decrypt. So the question is, does the body parser decrypt the password, or are we just dealing with client-side stuff at this point? It's not encrypted at all. I mean, it's encoded, right? Yeah, that's variable destructing. You're right. And there's also spread, which we'll talk about in the next project. And I think constructing is another one. But so this is exactly what sends. It's the body that your browser sends to the HTTP post body that it puts into the request is encoded, right? But it's not encrypted at all. This is still plain text. It just puts all your key value pairs together with ampersands. So it does break out the encoding into key value pairs and put it into an object, but there's the encryption layer at this point would be HTTPS, which we are not using on our servers. Because if you encrypt anything in JavaScript, there's no point in doing that, right? Anything you can encrypt in JavaScript, I can see the key that you're using to encrypt it, and I can encrypt whatever I want with it, right? So there's never any point inside JavaScript to encrypt something. You let the browser handle it with HTTPS, and you're good to go. We aren't doing that, so all this stuff will be flying over plain text. Anybody that's inspecting your traffic will be able to see it, but we're not going to make this overly complicated, right? So yeah, that's rec.body, and that's why we're using body parser. So we actually have rec.body.userid.password and .name, depending on what we send, right? So this is another thing is for the post to user. This is the thing that registration sends to, right? This one has 3 different fields. It's got name, user ID, and password, right? So those are the 3 values that we're going to see at this endpoint, right? Rec.body should have 3 things in it. And we need to check to see if all 3 of those things exist, doing kind of 3 different versions of this if statement. Leaving that up to you to duplicate this if statement and kind of change the error and the variable you're checking, right? But over here in login, you don't have to type in your name to log in. You just need your user ID and your password, right? So, I know I'm saying right a lot and it's probably getting annoying, right? But if we go up to user auth, that's only, the rec body up here is only going to have the user ID and password. It's not going to have the name because the form that we're expecting to hit this endpoint is not going to have a name field. Okay. God, it's already 4:40. Okay, so suffice it to say, without this session middleware piece, you would just have a set of rec.cookies, and you'd have to get the cookie value for the session. You'd have to go find some place in memory that you'd stored stuff. And this does the same thing for you, right? So if you were to write or read from rec.session, like this, for example, this is once you get past login, you're at the info, you just want to display info about the user. The session object should have a user ID field in it. This is populated by that middleware piece. That middleware piece sees the random value in the session cookie and goes and looks up memory for that corresponds to that random value and puts that memory into rec.session. Also, if you write into rec.session, it'll do the reverse. If up here I do rec.session.userid equals Bob, now it will actually generate that memory, generate a random cookie, and attach it to the response. So this does, all you have to do is read and write into rec.session because middleware handles everything else. Okay, that took longer than I thought. Any other questions on that before I switch over to a little bit of XHR and promises?
Can you explain the session cookies again?
Yeah, so session cookies work by, you have, let's see, you generate some random ID on the web server. Somewhere on the web server, you're like, all right, I need to create a session. I'm going to generate this random ID. And I'm going to associate this with some spot in memory. And then I can put variables or put stuff into that slot in memory. So I can put the username into that slot in memory. I can put an image. Please don't do that. But yeah, you can put an image in there. You can put the password in there. You can put all kinds of stuff in the session, in that memory that's tied to that random ID. The only thing you send to the client is a cookie that has that random ID in it. every time the client comes back, it will attach that cookie to its request. So every time he comes back to you, he's going to have a cookie that says, hey, that's my slot in your memory is this ID. And so you go, when you get that request, you go look up in your little section of memory things, and you're like, okay, ID number 5. Okay, pull that off the shelf. Boom. Now I know that you're Craig B because you gave me a random number, and that random number corresponds to some memory, and that memory says that you're Craig B. You don't really have to worry about all that and the specifics of how that works. It may have, I got to remember if it's on the midterm, it's not going to be on the quiz or anything like that. All you have to do for this project is read and write into rec.session. So user ID is the only thing you have to mess with. And you just have to, after they successfully log in, so it's not here, but the only time you really need to mess with it, this thing reads it, and this thing requires session.userid to exist to show you this page, right? I'm still saying right a lot. Down here, if they do all of this stuff right and they actually authenticate correctly and they give you the right password and the right password matches to the password hash and all that stuff, and you are sure that you know who this person is, then you set rec.session.userid equals user ID, right? Because we already pulled that out. So this person is logged in. He said, hey, here's my user ID. Here's my password. You validate a bunch of stuff. You make sure that their password matches like the hash that you have and all that stuff. And once you're like, okay, this person is actually who he says he is, let me write who he says he is into rec.session.userid. And from that point on, he'll be able to go down to user info and actually see this stuff, because his browser will get a random cookie, and that random cookie will say, here's your memory. And that memory that it points to will have a user ID in it that will be the user ID you wrote to up there. Did that help at all?
Yeah, thank you very much.
Cool. All right. I'm a noob, but have been looking into cookies versus local storage for auth tokens recently. Do you like cookies more? Is that why we're using it? So sessions can use local storage, but then you actually have to tell the browser to attach local storage to a request. So for the thing with local storage is generally it does not get automatically attached to the request. So if you just mash the button on a form without any special JavaScript work behind the scenes, I don't think local storage stuff makes it out of your browser, right? Cookies are a little bit more hard-coded to, like, cookies are almost always sent with requests. So it's a lot easier to deal with cookies without any client-side JavaScript and actually ensure that they work correctly. If you're doing an entire like client-side page and you want to save the state of a form so that when they reload, it'll all come back correctly, that's a good thing to do with local storage. But if you want to use like sessions or something like that, where you want to send that session data to this back to the server all the time, and you don't want to have to encode it into every XHR request with custom JavaScript, then use cookies, I think. Unless local storage can all of a sudden attach to requests, but I'm not sure. I haven't, that's not my experience. You may want to Google that and make sure I'm right. Okay. So we talked about forms the other day and how like you send a request. Wait, let me just close that one. We don't need to be looking at that code. That didn't show you anything, but still, we need to be looking at this code. Project for redacted. That's right. Okay. So this is all the same stuff that was in the other one. But we already talked about when you mash this button, the browser sends a packet to the server with all of these input fields encoded in the bottom of it. The server sends you a response. The browser expects that response to be a renderable HTML page or a redirect to another renderable HTML page. It doesn't sit here on the registration page, get new data from the server, and then stay on the registration page. It sends that data to the server and gets a new HTML page or new like 302 redirect to a new page, and then it renders that new page in the browser, right? XHR is different. This is an example of an XHR request. It is something that will not change the location of your web browser. I mean, you can do that, but you'd have to actually do like window.location equals something else, or some, you can do it that way, but by default, this just sends a background request to the web server and then tells you when it comes back and you get to do something with the data. And that's why we're using this for the username check. So checking to see if a username exists. We tell Axios, and Axios is just an extra thing. For the server side, we'll be using server-side Axios, I think later on in one other project. We don't have to worry about it now. But it's a nice library because it works exactly the same in the browser as it does in the web server. The only difference is here in the browser, in Node.js, you have to actually require the package, versus in registration index, it's just included with the script tag at the bottom of our HTML. Either way, the Axios, after you get past that first line, where are we? After you get past this first line, all of this code here will run exactly the same. So it's really nice. And this is just saying make a GET request. You're telling your browser to make a GET, an HTTP request packet with a method that's GET to this long URL. So I'm kind of hard coding it as localhost. For you guys, I would really, really ask for you to make it dynamic, not absolute. So this is going to go on the registration. Relative, thank you. This is going to go on in registration. So this will be loaded, IP/project4/registration/ and you don't even need this extra. You don't have to put index.html here, remember, because it's called index. It'll just know what you're talking about if you make that. So like http:// like this whole thing will be loaded. You'll be on this page when this runs. So from this location, you have to go up one directory, over to dynamic, and then into user exists. So you can kind of just do that, right? This relatively says, and that means that if you do the same code in project 5, it'll work exactly the same, because we aren't mentioning project 4 or project 5 anywhere in this URL. We're just saying go up a directory, go over to the dynamic directory, and then go to user exists. And if we go over to our server code, we're looking for user exists. Nginx is doing the proxy from dynamic to Node.js, so that's where that piece comes from. So that's how all of this path stuff works, right? There is an optional thing that we'll get to probably in the next project. There's an optional set of config args where we can, if we were doing a post, we could do like body equal, some data, headers, can be like some array of key value pairs, that kind of stuff. We don't really have to deal with any of that. We just want to send a basic request. And so we're sending it to this URL, and we're attaching a GET parameter, right? So before I said forms probably should send stuff in the post body because you don't want it to show back up in your browser history. But this is just a query, right? This is the same thing as sending a query request to Google. It's fine if the world sees that I'm looking to see if user ID exists on the server. So it's also a lot easier to construct it as one URL than to have this extra thing where, like, this is the other way you could do it. You could kind of get rid of all of this, and you could say body user ID and then whatever variable I had, value, right? So this would be the other way to do it. If you really wanted to send it in the body, you'd have to do this whole second argument to Axios, and it's kind of a pain. It's so much easier to just build out a URL with a question mark in it, and then some key value pairs, or in our case, one key value pair. Okay, this sends our request. It returns a promise. Pet. Okay. Let my promise equal this. So normally, if we're dealing with callbacks, right, we would have to pass another function into this. This is not how Axios works. Don't get your hopes up, but we'd have to have like function or like a handler, right? So we'd have like handle response. And so we'd have to define like const handle response equals function, response from server, code to do stuff with response, right? So this would be like the old way, the way that we're used to doing it, hopefully, for doing asynchronous stuff, right? Because it is asynchronous. We send something off to the server, could be a millisecond later, could be 2 hours later, probably not 2 hours, but could be 15 seconds later. We don't know how long it's going to take for the server to send us a response. So we have to do this asynchronously. We can't just sit here and wait for it, because while we're waiting, the user won't be able to type anything into the page, right? So this doesn't work with callbacks, though. This works with promises. A promise is an object that gets returned that's like, hey, I promise, hold on to this variable, and I promise to get you an answer when I have it. And so you take that promise and you say, whenever you get that promise, when you get an answer back, then run this code. And this is fat arrow notation, but it's equivalent to function. There. So this is right. So we have .then, we have this function, and whenever this promise comes back, it's going to run, the promise is going to run this function and pass in the response from that we got back from the web server. The data of that response is going to be in .data. There's also other stuff like the response code, like 200 versus 404, and a whole bunch of other like headers and cookies that came back with the request and all that stuff. That's all in this response object. And promises are chainable. You don't really have to know this, but I'm going to kind of go on with promises till like the end of class today. So promises are chainable. So let's see if I can get this stuff to work. Let's go over here. And let's see if I can get that to start. Let's open a new one. SSH to the same server. So now I have two windows running on the same server, and I'm going to go to project 4 directory. What is it? Server. And I'm just going to type node. I'm going to drop into a node command line. So I'm going to require Axios. Yes, paste anyway. What? You're in the... Oh, right. I haven't installed Axios because we don't need it for server-side stuff. So that's why that didn't work. Okay, so require... Yes. So now we have the Axios thing required. We're going to try this code here. I know. My promise is not defined. Value is not defined. Oh, okay. Well, let's just replace value with like correct B. Let's hard code the hell out of that. This pasting thing is going to get annoying. My promise is not defined. Identify my promise has already been declared. Ugh. All right, let's redo this. Copy all this. All right. So it gave me an error, unhandled promise rejection, error request status code 400. That's because it's relative. Wonderful. Yep, F. So I'm going to change this back to Sublime first. And because this didn't load from anywhere, like in the browser, this relative stuff would actually work. When I'm just running it from from a node console. Nope, not S. Let's try this. This maybe will work. Hey, there we go. So it says exists false. So what happened back to Sublime. It actually, this is the response we're supposed to get back from exists. We get this object that either says exists true or exists false. So I'm just gonna, this is the actual thing it console logged, right? And I think if this were to be admin, it would say exists true. So we get this nice little JSON object back. I can actually modify this and chain to another .then. So I can do, let's say I want things to be like more broken up. And this would be useful if like you have multiple layers around this thing. So let's say you had like, I don't know, I don't know, you had like thing 1 that does stuff, and then it calls, inside it, it calls thing 2 that does some stuff, and inside that it calls thing 3, and that does some stuff, right? Okay, so this has, we want to make this asynchronous, so it's already got a callback. We have to put the callback in and pass it all the way into all these 3 layers. So all 3 of these functions that we wrote now have to have a callback in it. And if we wanted to have something that we also wanted to call a function if we encountered an error, so we'd have like an error back. Okay, so we added in this new functionality where we're like, okay, well, we can call this other function if we encounter an error. Now we have to wire this other function all the way through all 3 of these classes, right? Bringing error back. Oh God, I just thought of a terrible, I'm not even going to subject you guys to that. Okay. So this is the problem with using callbacks, right? Whenever you use more callbacks, you kind of have to continue to add more things, more callbacks to this thing, right? If instead these return, so it kind of takes the callback idea and flips it on its head, and instead of taking callbacks as arguments, you return promises instead, right? So now thing 1 just returns the promise from thing 2, which returns the promise from thing 3. Additionally, this thing might say, all right, I want to return the promise from thing 3, but I want to modify it. Every time you call .then, it returns a new promise. Those other programmers don't know how to act. Okay, so I might modify it, but every time I call a .then, it creates a new promise for us. And that new promise is going to have the values of whatever I passed in. So let me get rid of this catch for a second. I'll talk about catches later, probably not today at this point. So let's say here, I just want to make it easier to get the data. So I just want to return response.data. Okay, so now this generates a new promise. So I can say like, let my second promise equal this. And all this gets tied together, so we can take out all these variables and we can just do .then, right? God, I need to stop saying right. You know. Okay, so .then, I'm down here, I'm gonna do my second promise .then. Eh? Am I right? A. And inside here, forget about it. This will actually be, and so this is just, you know, whatever arg we call it, but here this will be response.data. This will also, arg here will be response.data up there. So arg will be this thing, right? Right? Oh, now I'm just going to do it because it's funny. So whatever we return from this first promise gets passed in as the argument to the next promise, which is nice because now this hypothetical thing 1, thing 2, and thing 3 can actually modify the value as the value gets returned and bubbles back up. But it does it by registering callbacks and kind of encapsulating each promise with a new promise. So this will become more clear as we use more promises, but for now, we don't even need to save this promise. We can just do .then response. And so this .then, this is the whole function call. Like this whole function right here is the parameter that gets passed into the .then. We are passing a function pointer into .then. It is the same thing as doing const handler equals this console.log response.data, and then down here we just pass in handler. So .then just takes a function pointer. It's nothing special. It also returns a promise. So we can attach another .then. And to make it easier to read, I kind of just put these on new lines. As long as you don't put a semicolon at the end of this line, you can kind of just keep .thenning stuff and it will just follow along nicely. And I'm gonna, instead of making a handler 2, I'm actually gonna write this function in place. So I'm gonna do data is, and up here I'm going to console log response data is. Okay, so let's see, cancel out of all of this. Let's see if we can get this to do what I think it'll do. Here's hoping. Yes. Ha, 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 ha. Uncaught syntax error. What did I do wrong? Data is not defined. What did I do wrong? Program with the insert function running. Handler equals response that. Require Axios, call Axios, .then invalid REPL keyword. I guess you can't do it on multi-line when you're in the Node.js console. Womp, womp, womp. I might be able to do this multi-line. Well. Let's just make all this one nasty long one-liner real quick. Okay. Let's try this again. All right, so that actually worked. The first thing we got back with, and I'm just going to copy this back so we can see what the hell it did while we're also looking at the code. Sublime. Okay. So this was us defining our const handler. That's me pasting in this part. This is me defining our Axios requirement, which is this part. This is me running our actual line of code. And then these 3 lines are the output. So the first thing is it got a promise return. So after all of this stuff with the .then at the end, well, we can separate this back out now because I don't feel like copy pasting it again. With all these .thens at the end, it ran all of this code and it still returned another promise that we could attach yet another .then to. So that's what this is. It's saying, hey, that huge Axios command with all the 3 .thens at the end, or 2 of them or whatever, it returned a promise. And then it actually resolved that promise and called our first handler, which is this function pointer, which is this code here, which is why it says response data exists false. And then in the second, and then we return response data. So in the second one, this argument is just data. So I don't have to do, data.data, right? Let's say we name this thing response as well. So now the argument is response in both places, but here we would just use response. So because this has returned a subset of the real response, which is now being passed into the next callback. So there's also error checking. I will probably not get into that till Monday, hopefully. Promises, generally speaking, need 3 or 4 times of me talking about them before they start to make sense, which is why almost all of the next project is promises, creating them as well as using them way more heavily. In this project, you're just getting your feet wet. You just have to like have 1 dot then. You don't need 2. You just have to have 1. And it just needs to be a function, and we can call it handler and define it up top just to make it easier to see. But this response.data is going to have exists, false, or true in it. So exists is going to be response.data.exists. Okay, with the dot in there. And then we would call something like, oh, I don't know, that function I gave you for whatever it was, set username status. Where's my index.js? I think this is in the value set username status. So we call this, and what do you know? It takes an argument, and the argument's called exist. So you really kind of just do that. And please, God, change this URL back to the right thing and put a value at the end of it. And you don't need this requirement. What's the point of the whole Axios thing? Just to check if a user ID already exists? Yes. This is the part that whenever you type into or paste into the username box, it's going to run this on username change function. And this on username change function is going to do something like this. And so it's going to send off an Axios request to the server every time the username input field changes. And it's going to get the response back from the server, which tells us whether that username exists on the server or not. And it's going to call set username status, which is going to set the thumbs up or thumbs down next to our username checkbox. That's the entire point of this. Okay. I think that's all I got today. I think you guys will find the quiz extremely easy. Let me just give you a preview of the quiz if I can switch to the right thing. It is published, right? Let me make sure. Quiz number 6, it's in a published module and all that stuff. The password is green. It's all uppercase. I'm going to put that over here, and I'm also going to put it into our chat. And if we preview it, it just has 1 question. If you don't like green, then maybe you shouldn't like this. What will we get if will we get it wrong if we answer false? Yeah. I know. James Lynn, shout out to my man James. He was like, oh my God, so that's like pick the right answer. And it's like, this is the right answer. This is not the right answer. This is also not the right answer. And why are you still reading these answers? And he actually picked one of them that was not the right answer. And he sent me a message. He's like, I was playing WoW. I wasn't paying attention. And I'm like, you get 1. All right, that's all I got for today. Get out of here. Enjoy your free 6 points. Have a nice day.
Hi, Craig.
Yep.
So cookies are basically just key value pairs that get put onto a packet?
Yep.
Okay.
It's also got stuff like only send this key value pair to to this type of server, or when you're using HTTPS, or until the time limit expires, and all these other metadata things. That only gets sent to the browser. The browser never sends all those metadata pieces back to the server. It just sends a bunch of key value pairs, which are like all of the it's an aggregation of here's all the cookies that I know I should send you that I have in memory.
Okay.
Hey, Craig.
Cool.
Yep.
If we have is it secure if we have a cookie that like we give the browser a cookie from the server? Isn't that what you're supposed to do? Right?
Yeah.
When they provide the correct login credentials.
Mm-hmm.
And if that value is like a third value, not a value they entered in, like some type of ID value that links back to the database, that is a session cookie, correct?
Right.
Okay, cool. I just made one of those accidentally. And now I know what those are. That's really cool.
And so now you
login for senior design, and that's exactly what I did.
So there, like I said, there's upsides and downsides and 5 different ways to skin that cat. But yeah, you pretty much just reinvented session cookies, and any competent language is going to have session cookies already made. So you may want to take your kind of mostly done and maybe buggy version of it and rip it out and use the built-in session stuff.
It uses like the cookies JS, the npm package, and I just
okay
set the name of the cookies off, and the value is an ID number that is attached to the database.
Okay.
That they can't release. I guess you could type in that number, but I have to whatever.
Well, what's the number like? How big is the number space for those?
It's small because I'm just testing it.
Okay. So I could try 1, 2, 3, 4, 5.
That would work now, but eventually it would be, once I do the encryption and stuff, it should be a big long string.
Okay. I mean, you may instead want to just take the current timestamp and turn that into a SHA-256 hash.
Okay.
And that'll make a really nice long string that's going to be hard to pick through.
And that could be their user ID.
Yeah.
Yes.
Or that could be the value of the auth cookie. Right.
Okay, cool.
Yep.
That makes sense. Thank you.
Hey, Craig.
Hey.
Thanks, Craig.
Go ahead, Ashton.
I was just saying thanks. My bad.
Okay. I was going to ask about, so we have our midterm next week, right?
Mm-hmm.
Do you have any idea of certain topics we should look at or things to study?
I do, but I'm not ready to tell you guys about it yet. Hopefully by this weekend I'll have a study guide. I'll post in Slack, and it'll be another little module thing inside, not a module, but a page inside.
Okay. Cool.
So I'll let you guys know. I'm still kind of working on it, but forms, a little bit of Ajax, a little bit of promises, which depending on how much I feel comfortable with how much we've got through promises, I might rip some of that out. And stuff like CIDR addresses, HTTP responses, HTTP requests, what are the parts of a URL? What are the parts of a packet? Are headers cookies, or are cookies headers, or, that kind of thing.
Cool. Thanks.
Yep, no problem.
And the correct answers to the quiz, the past quizzes, are they released the day after?
I think they're released a week after normally.
Okay. All
but
right,
if you can't get to any of them, let me know, because I might have screwed up some dates somewhere. So, but I also want to go over pretty much everything you need to, the study guide that I'm going to put out. I want to go over that on Monday, and I want to go over quizzes on Monday. So.
Okay. Cool.
All
right. Thanks, everyone.
Yep. You too.
Appreciate it.
You're welcome, Rhett. All right. I think we're all done here. I'm going to close up shop. See you guys on Slack if you need anything.